Welcome to the lectures on problem solving and programming in C. This is lecture 18 and the title of the lecture is modular programming. In this lecture, we'll see how to decompose a problem into subproblems and solve them, the subproblems independently and connect the solved subproblems to solve the actual original subproblem. So what is modular programming? Modular programming is basically decomposing a problem into subproblems and solving them. Okay, let us see what it means. For example, suppose if I have a number, I have a black box here. I call it a module. It takes some input, some A, and gives me the check. Suppose if this block box is to check prime number. Okay, so let me say if I pass a number n, what it says is it returns yes or no, yes or no. So or else 1 or 0, 1 or 0. 1 stands for yes and 0 stands for no. Okay, or else true or false, true or false. What does it mean? This is a module or procedure. This is called as a module. Block box called as module or procedure. The procedure. So this takes an int. If to this block box, if we give a pass a number n, I read a number n from the user and pass it to this function, this module. In programming languages, it's also called function. Okay. Then inside this, it has some piece of code which checks whether n is prime or not. If the n is prime, then it returns a value 1, otherwise 0. To the caller, whoever is calling this function, he will receive a return value in the form of 0 or 1. If he receives a 1, it means that the number is prime. If he receives a 0, if the number is not prime. Okay. So this is what called. So suppose if you return a module procedure function like this, what happens is wherever you require the functionality of checking whether a number is prime or not, so you can use this functionality, this block box, call this block box to solve your program. Okay. What is the advantage by decomposing a problem into modules or procedures like this? What happens is when you have a decompose a problem into one or two submodules, so each submodule has a specific requirement. Okay, what is the input? What is the output? This is input, and this is output. Output. What it returns? Output means what it returns to the caller. So input means what it receives from the user. Okay, caller. So suppose each function has a specified specification. So each module can be implemented independently. Suppose if you have a team of developers, you can give one module to each one person so that the development will be fast. That is one advantage. And another advantage is suppose if there is any error in any function. So if you just modify one function, automatically whoever is calling this function, all those places, the corrected function will be affected. Otherwise, suppose if you instead of function, if you are writing the code multiple places, so what happens is you have to correct at multiple places. Instead of that, if you just write one function and call this function as and when you require this functionality, so if there is any error or bug in the function, if you rectify it one place, it will reflect all the function calls. So that is why maintenance will be easy. Program maintenance will be easy. Okay, program development and maintenance will be easy. So, and also it brings out the code reusability. So code reusability, because you are writing once and calling this function at multiple places, it means that code is reused as and when it is required. Instead of writing the code again and again, we are reusing write once and use many times. So it is procedures will help you to write once and use many times way of programming. Okay. let us go into some examples so that we will understand what is this. So let us try to write some procedure for how to check if a number is prime or not. Okay. First write a procedure and then see how to use it. Okay. So let us say what we suppose if I want to check whether the number is prime or not. Okay. So what we need to do? We need to do okay. So prime I will write a procedure, prime checking procedure. Okay. Procedure is prime. Is prime in the bracket n. Okay. This is the difference between this is n is argument. Okay. Whoever is calling the is prime function, he has to pass a number n to the function so that it returns a value. What is the input? This is the description about the input. A positive integer number, as argument. Okay. Then this is important. As an argument, you don't read the n value inside the function. This is passed as an argument. Okay. So this is called argument. Output returns 1 if n is prime, 0 otherwise. Okay. It returns a integer value 1 or 0. Then it returns one value 1 if the number is prime, otherwise 0. Let us say this procedure follows the same pattern as an algorithm. Only difference is you write here procedure. Okay. And then input output. Input actually what you are passing as an argument. Usually inside the procedure we don't read from the keyboard. Okay. We take the arguments from the user, who in turn will read the value from the user keyboard and pass it to the corresponding function or procedure. Okay. What is the logic? We no need to check for input validation inside the function, because input validation is the duty of the caller. We can silently assume that the user is passing a correct expected value. Okay. And so for I equal to 2 to n by 2 do. Okay. If n mod I is equal to 0, then it means that there is a factor other than 1 and n. So it means that this is not a prime. Return what is, if it is not a prime, what you need to do? Return 0. Okay. And if end for. Suppose for example, we are running from I equal to 2 to n by 2 and we are checking for every value of I whether the I divides n. At any instant, if we find that n mod I is 0, it means that we found one non-trivial factor. So it means that number n cannot be a prime because it has a one non-trivial factor. That's why we are returning 0. So after checking all the values of I and I2 to n by 2, if we are not able to find not even a single factor, the control comes here. In that here we can safely return 1. Okay. Right. This is a function. So how do we call this in our algorithm? Suppose if I'm writing an algorithm to check whether the number is prime or not, let us see. Algorithm prime check. The same function we have written earlier without any functions. Using simple logic we have used. Now this we will write the same algorithm using functions. What is the input? A positive integer number. Number n greater than 1. What is the output? Check if if n is prime or not. Okay, begin. So since this is an algorithm, we need to do read input and then input validation and all those things should be done. Input n, put n. If n less than 2, then output invalid input and stop. And if otherwise, what we need to do? P status, prime status is equal to is prime. So we have written this function, right? What we do is this function. We'll call this function by passing the value of n. Is prime of n. So this returns a value. Right? 1 or 0. So I'm checking is p status, for prime status. So once this function is called, n is passed, and this function returns either 0 or 1. If p stat equal to 1, then if the function returns 1, what does it mean? Output number is prime. Else if it returns a 0, then what we need to do? We should output number is not prime. Okay, and if end. Okay, so you see here in earlier when you are talking about prime checking problem, we have written this whatever this logic here only, right? Here only. Now what we did, we have separated it out. Written it in a function. Now, for example, if I want, imagine in circular prime also there is a logic to check whether a number is prime or not, right? So I can use this function there also. So that is why it is write once, use multiple times, use many times. Okay. And then if there is any change, if I make any change in here, automatically wherever this function is called, all those functions will be reflected. Okay. Let us write this function. See what let us write this function, type this program in a C file, VI prime modular.c. I'm just giving a meaningful name to the program. So there is the hash include stdio.h. Okay. So what I will do is first I will write this function first. Algorithm first. Okay. Int bit. I'll convert the algorithm to a C program. Okay, what is there? There is input n. Input n means int n, printf, enter a positive integer number, scanf %d %n. This is for input n, right? This is the equivalent statement for input. Then there is an if statement. If n less than 2, or you can even write less than or equal to 1 also. So then there is an output statement. I have put equivalent is printf invalid input and then return 0. Next there is this p stat. P stat is a variable, right, which is not defined previously. So it's what kind of data it holds? It holds either 0 or 1. So its data type should be integer. Int p stat is equal to is prime of n. This is how you call in C. C statement ends with a semicolon, right? So it's also ends with it. So this is a data type of this variable, and then function call, and then here, right? Then if there is if statement, right? If statement, if I return the complete if else block, empty if else block. So p stat is equal to 1. Printf number is fine. Okay. Else printf number is not prime. Okay. Right. Now what I need to do after outside this block, outside this main is one function, right? This main is one function. So similarly, I have any C, basically a C program is combination of functions, connection of functions, collection of functions. One default function is int main is the function. Like that, here I'm writing my own procedure, which we call programming languages. We call it as a function. So I need to define this function also in the program because my program uses a function called isPrime. Okay, that is why isPrime also should be done. So while converting a procedure to function, procedure in algorithm, procedure into C function, what we need to do is we need to specify what is the data type of this return value int. What is the name of the function isPrime. And then what is the data type of arguments? Argument is 1 and its data type is n, int n. Then this is a C. You see here int main, what does it mean? Main is a function name which returns an integer value because you are returning 0 or 1 here. So, and here it doesn't take any arguments. This version of main doesn't take any arguments. Similarly, this isPrime is a function, name of the function. It returns an integer value. Okay. And what is its input argument? It takes one argument n. Name of the argument is n, and its data type is integer. It means that it takes a integer number as argument, right? User passes an integer number as an argument and returns a integer value as an argument, which is actually 0 or 1. Now see here, now we have this for loop. For int I equal to 2, I less than or equal to n by 2, I plus plus. This is very similar to how we convert a for loop in algorithm. If n modulus is percent I is equal to 0, then return 1, return 0. Otherwise, return 1. Exactly, you see here, I just translated this procedure into here. Okay. Now completed. Now completed. Let us recompile this. So we got a syntax error. What is the syntax? Let us read the syntax error. Implicit declaration of the function is prime. Okay. Why this syntax error is coming, I will tell you. See, the definition in C actually statements are read top to bottom, right? So one by one. So by the time the control compiler comes to this statement, it doesn't know anything about isPrime function because isPrime function is at here. So to make it aware, the compiler aware of this definition, this is called definition. What we do is either we should define this function before the main, or we can specify the prototype of this function. Prototype, this is prototype. This is the prototype. Prototype of the function just before the main here. What I will do, I will in the prototype there should be a semicolon. There should be a semicolon. So this is the prototype of the function. What it says that in this file there is a function named isPrime, and then which takes an integer as an argument, and I can even remove the n also here. What is it says? In this this file requires, this program requires a function called isPrime, which takes an integer as an argument and returns integer as a value. So this is called prototype of the function. So whenever you are using a function, Either the function should be written before the main, or you should specify its prototype. In the prototype, you no need to mention these variable names. It's optional. I can even mention int n. That doesn't, it's not harm. But what is needed is just the data type of the variables arguments is just needed. This is called prototype of the function. Prototype or declaration of the function. This is called definition of the function. Okay, function definition. Now let us compile this. It's compiled now. Enter positive integer -5. It says invalid input. Then 7. It's a prime. 9 is not a prime. Okay, yeah, like this. There is a typo here. The number is prime. Number is prime. Okay. Like this, you can split. Now, what I will do is I will also teach you how to split this module, how to write this module in different files, and then call this function in multiple C programs. Okay. So cat, what I will do is I will put this program in separate file. Okay, this function separate file way is prime.c. Prime.c is prime.c. Okay, just this function, this C file doesn't have main function. It only contains is prime, this function. Okay, now let us modify this program. So prime mod. So what I can do is I can remove this. I can remove this function. Okay. So what I can do is I can include that file. Hash include. Okay, fine. Doesn't make it. Does no need to include it. So let us. I can even compile like this. CCC. So prime mod, and then is prime. I can pass the is prime. The is prime function is actually not there now in the prime mod.c. It is there in the separate file. Since we have specified the prototype in the prime mod.c, and we are while compiling, we are also passing the definition of the is prime function, which is there in is prime.c. It compiles successfully. This is how you can separate out your module into a separate file. Suppose if you have five modules which are relevant to some functionality, specific functionality, we can write them in a one C file, and then that can be included in as and when required. So we are writing only once, but we are using it many places, many times. Okay. Now let us modify our circular prime program. Circular prime program. Same thing. This is a circular program, right? Circular function. So here also I require hash include. Doesn't need hash include. So we need the prototype of the function use prime. This is the prototype of the function. Okay. Now here you see here instead of this so the number is generated. So okay. So what we need to do? We need to check whether number is int pstat is equal to is prime of n. Okay. If pstat is equal to 1, so 0. If it is not a prime number, then automatically we can conclude that if we are calling is prime function. So basically in circular prime program, we are checking every circular rotation number is a prime or not. So initially we check for n, and then we do the next iteration, right? If the is prime function is called, if it returns a value 0 or 1, which is stored in the pstat variable. And then if pstat is 0, it means that the number is not prime. Okay. So the number is not, we will display number is not circular prime and return 0. Otherwise, after checking all these numbers, all these circular rotations, if we say that number is circular prime, okay? GCC circular prime, and then I need to pass this is prime function. Compiled, okay, 3779 is a circular prime. We know that 3779 is circular prime. 39 is not a circular prime. Okay, you see here I wrote the is prime function only once, but I have used it in two places, two instances, two problems. One is just checking a prime number or not, another is checking whether the number is circular prime or not. That is why modular programming supports write once and use many times. And this way of solving problems will help you to develop programs or solve problems faster and maintain the programs faster. And also it brings in code reusability, because you see here the prime checking logic is there. I need that logic in the prime number checking problem also. I need that logic in the circular prime also. But I have written only once and I reused it, reuse the code reuse. So modular programming will brings in code reusability also, right? Let us move on to the next problem. So how to count digits? Let us take counting digits. Counting digits. So we know we have written algorithm to count digit, right? We will write a procedure. Procedure count digits. And input n is the argument. What is the input argument? Input a positive to integer number n. Output returns the number of digits of n. Digits of n begin in. So we know that we don't need to n, right? So we need to count a number of digits 0. While I'm just writing that logic n greater than 0, do count plus plus n equal to n by 10, and while count return count, sorry, while return count. So what this function does is it takes a number n as argument and it returns the number of digits of the number. This is a logic to compute the number of digits. You keep dividing number by 10 until it becomes 0. So once it becomes 0, by the time you got the number of digits in the variable count, we are returning that. Okay. See here, this function can be used in many places. For example, in reversing a number, we can use um, in circular prime also you can use, because we need to count how many digits are there in the number. So this kind of function, a functionality which you need multiple occasions or multiple places or multiple problems, that can be written as a separate function. Okay, this function for counting a digit. What is the next digit? Reversing a number. Reversing a number procedure. Reverse of n. Okay. What this takes is, it takes an n as an argument and then returns the reverse of the number n. Input the positive integer number, integer number for n. output returns. See, when you're writing an algorithm, we'll say that it prints, it displays, it computes like this. But when you're writing a procedure, you're using the term returns. Returns mean it will return the value. Returns reverse of n. Okay, begin. Okay, right. So how do you reverse a number? So reverse is equal to 0 while n greater than 0 do dg is equal to n mod 10. Then reverse is equal to reverse star 10 plus d n equal to n by 10 and while and return reverse. The logic we have seen in earlier programs, right? Return reverse. Return reverse. Okay, this is a function. This is a function which checks whether a number is, or it takes a number n and returns the reverse of the number. We are computing the reverse using this logic, which we have discussed earlier. Reverse is computed using this logic, and the reverse is actually incrementally. Incrementally, reverse is computed, and then reverse variable contains the reverse of the number. Then that we are returning. Okay, this statement return reverse. Okay. Now let us see. Let us try to write a program which checks whether the number is palindrome or. Okay. What is a palindrome? Palindrome are basically palindrome. An application of this is palindrome. Palindrome. An application of this is palindrome. Okay. Suppose 121 is a palindrome. Because the number and its reverse are same. So 123 is not a palindrome. Is not a palindrome. Okay. Because 123 reverse is 321, which is not equal to 123. Okay. So what we can do is we read a number n, then we compute the reverse of the number using that function, whatever written, and then check whether the reverse and number are same or not. If both are same, then we say that number is palindrome. Otherwise, let us write this program via palindrome. Okay, reverse.c I will write in separate file reverse. Okay, let's hash include stdio.h. So int main reverse of a number. What we need to read n. Enter a positive integer number. Scanf %d ampersand n. Okay. Then we do input validation if n less than or equal to 0. Printf invalid input. Then return 0. Okay. Then otherwise what we need to do? Int reverse. I need to compute reverse now. Reverse is equal to reverse of n. I'm calling this function which takes n and returns the reverse of the number. Then what if n equal to reverse? Then printf output number is a palindrome. Number is a palindrome. Else, otherwise, output number is not a palindrome, right? Then let me write this function definition by is a reverse function. Reverse function is this, right? Reverse function is this. What is the return type? Integer. This is my function definition. The reverse name of the function is reverse. It takes an integer n as argument and returns an integer. Okay. Then what is the reverse equal to 0? So int reverse equal to 0. Then there is a while loop. While n greater than 0, n greater than 0, int d equal to d to be declared, right? N mod 10. Then reverse equal to reverse star 10 plus d. Then n equal to n by 10. Okay. After that, return reverse. This is the function. Also, as I discussed, we also, since we have written the reverse function after the main, we should specify the prototype of the function. Int reverse int. So reverse name of the function is reverse. It takes an integer argument and returns an integer. So this is the prototype. Prototype or declaration ends with a semicolon, whereas definition doesn't end with a semicolon because it has brackets. Okay. Let us compile this program. You see, palindrome /c.3 1 2 1 is a palindrome. 1 2 3 is not a palindrome. Suppose if I give 100 minus 100, it's an invalid input. 1 2 3 4 3 2 1. It's a palindrome. It's a palindrome. Number is a palindrome. Like so, like this, we can write divide a bigger problem into smaller problems, and each smaller problem can be developed as a processor. See, not only one level, you can go more than one level also. So we have one sub problem. That sub problem again we can divide into another sub problem. Okay, like this we can distribute your program into multiple procedures or modules or functions that will help you to maintain or write your program or maintain your program easily. Then it brings in code reusability also. This is the introduction to the modular programming. In the next class also we will see some more examples of modular programming. Thank you.